Hi, this is Mr. Manley. In this video, I'm not going to work through any examples. I just want to try and give a sense for what logarithms are. And I'm going to start off with just 3 points, and that really should cover it. And then I'll take a look at just 2 operations with logarithms to help clarify or maybe wrap up the sense of it that I'm hoping students will get. So we have this logarithm, and it's really relatively new. Students that are watching this video maybe have seen logarithms once before, and this is only the second time that you are exploring them. So the first thing that I want to say about a logarithm is that one logarithm is an operation. And it's simply another in a long line of operations that you've learned since you started learning mathematics. First learned addition, subtraction, multiplication, division. How would I show exponents? I'll just say exponents, radicals. Anything else? I don't know. I don't think so. And then next is log. So it's this operation in a long line of operations that you have learned. So if nothing else, you should be able to walk forward through life being able to answer the question, what is a logarithm? It is an operation. Well, what does that mean that it's an operation? Well, just like addition and subtraction are operations, log is an operation. For instance, if I have the number 2 sitting here, minding its own business, and then I operate upon it, I know what that means value-wise. I had 2, now I have 3. If I do subtraction, I had 2, now I have 1. If I do multiplication, let's say I do 2 times 3. I had 2, I've operated upon it, now I have 6. I had 2, now I've got 2 divided by 3, now I've got 2/3. So I'm operating upon this 2, and I know what value is resulting from the operation. If I raise it to a power, I had 2, 2 to the 3rd, now I have 8. Take the square root. I had 2, now I have something between 1 and 2. Because I know what this means. I know that it means what number multiplied by itself is equal to 2. That's what that operation, the radical operation, means here. And I could put that into a calculator to get a better approximation, but let's just say that I know, well, it's some number between 1 and 2. If I wanted something, like wanted to do one that was more convenient, yeah, the square root of 9, I say, well, that's 3, because I know that 3 times 3 is 9. So now let's have this 2 sitting here, and I'm going to operate upon it with log. Now, one thing about this operation at this point, just like the radical, there's a 2 that's understood here called the index, right? So there's an index of 2 that we don't write. That index can change. For instance, I could do, instead of the square root of 2, where we have a 2 there, which we don't write, I do not write that 2. We just understand that there's a 2 there. I could change that, and I could have a 3. Just like there is a number understood there is a number understood with a log. If I don't write anything, there's a number understood here that is 10. So I'm going to write that 10 here, but just know that if I don't write the 10, it's understood to be 10. And then this could be any other integer, like I could have 3, and I could have 5, etc. And this is called, just like for the radical, that number is called the index. For the logarithm, this number here is called the base. That is the base of the logarithm, base of the log. Okay? So I'm going to go with base 10, and it might not be written. It could be written, but if it's not written, it's understood to be base 10. And what I want to do here is just say that just like I understand what that symbol, this radical symbol means, it means this. What number multiplied by itself is equal to 2? That operation has a meaning. It's the same with log. This operation, this log operation has a meaning. It means what power is 10 raised to equal 2. So think about that. That's 10 to what power is equal to 2? That's what this is equal to. Log base 10 of 2. That's how I would read that. I could read it as log base 10 of 2. I could also read it as just log 2, and people would understand that I mean base 10. I could also say the common log of 2. So this is just this special initial case where there's multiple ways of saying it. But the standard way of saying it that would cover me for all cases would be to say log base 10 of 2. So this is what it means. 10 to what power is equal to 2? Well, what is it? I mean, if I go 10 to the 0, that's equal to 1. So it's not 0. If I go 10 to the second, or 10 to the first, I should say, 10 to the first, that's equal to 10. Well, that's too much. So just going from 0 to 1 with the power, I've gone from 1 to 10. But I'm trying to hit 2. So just stop. If you need to, examine what I just said there. From 0 to 1, I'm going from 1 to 10, but I need to hit 2. So it's between 0 and 1. And in fact, if I plugged that into a calculator, I would find out that this power that I'm looking for has an approximate value, and I'll give you that approximate value. You might look for it yourself if you had a calculator handy. The log of 2 is 0.301. So this number that we're looking for here is 0.301. So that's what this is equal to, 0.301. All right, let's look at a convenient value, just like I did with the radical. Like I said, well, let's take this, now that we are reviewing what this operation means, let's look at one that we could actually evaluate. So what if I said, what is the log of 100? Now, if you review everything that I've been saying, you would know a couple of things here, and maybe you could answer that. What is the log of 100? So a couple of things that you would have to have caught on to are, one, that this is a base 10. So you would have to have picked up that. The other thing that you would have to have picked up is just how the log operation works. And I'm trying to tell you how it works right here. So I'll write it out again for this expression. What power is 10 raised to equal 100? Can you answer that question? I think if you think about it, yeah, you can. So log base 10 of 100, or log 100, or common log 100, however we say it, that is equal to 2. So I've actually gone a little bit farther than I wanted to with step 1 there. by saying that log is an operation. If you take nothing else, if we just erase all of that, please at least take with you that you understand, that you know that log is an operation, just like all the other operations that you've learned: addition, subtraction, multiplication, division. It changes the value of a number. All right, second thing is, why? Why do we have this operation? Why are you confusing me with this? We've got all these other operations. Isn't it enough? Well, here's the reason for this operation. Log is an operation, and something that it does is log is an operation that solves for a variable exponent. So I wouldn't say that's the only thing that log operations do. That's not the only thing that they're for. But that's something that it does that I think you can take with you and that you can use, help you to make sense of what is this logarithm and why do we have it. Log is an operation, number one. Two, that solves for a variable exponent. So if you think about all of the other operations, we can think about cases where those operations are used in order to solve for a variable. For instance, if I have x squared equals 3, what operation do I need in order to solve for x? I need the radical, right? I need to take the square root of both sides. If I had x divided by 3 equals 7, what operation do I need in order to be able to solve for x? I need multiplication. I need the multiplication operation. And if I have 3 equals 7 to the x, what operation do I need? This is a variable exponent, and this is where log will come in. And we'll take a look at why that is, or you can learn why that is in a later lesson. But for right now, just know that that's what we do with log. Now, you might be able to do it if you can follow what my step 3 here is, or my second thing is, and this is what I call the definition. The definition of log. What exactly is it? Definition of logarithm. All right? And I'm going to say that if a to the b is equal to c, then log base a of c is equal to b. So see if you can match those up and see how that works. If I have a number to a power equal to another number, and then the a becomes the base of the log, the c becomes what would be called the argument. And this is a word that I use sometimes that means what are we operating upon? That's the argument. And we're operating upon c in this case. And then the b, the exponent, comes over here. So if you can trace that relationship, if you can follow that relationship, I think in combination also with what we looked at earlier about what does it mean? It means this number to what power is equal to this other number. If you can do those two things, you should be able to evaluate and work with logarithms. So as I said, I'm just going to look. I've kind of already looked at a couple of them, right? Let's just review and go back and look at it now. And let's do it with the definition. So if a to the b is equal to c, then log base a of c is equal to b. So when we were looking at log base 10 of 100, and we were saying, what is that equal to? So matching that up with this with this, I would have that A is 10, C is 100, and B is what I'm looking for. And then taking this and plugging it in here should reveal the answer to us. So the A goes here, and I'm saying this A is going in that position. The B goes here. So I'm saying this B is going in that position. So you see I'm putting it in the exponent position. And the C is going in this position. And then when I'm looking at that equation, I'm saying 10 to what power, to that question mark there, is equal to 100, I can see, oh yeah, it's the question mark is equal to 2. Of course, in a math class, we're going to do that as a variable, right? So maybe we'd say that it's equal to x. And so I'd take all these question marks and I'd change them to x's, because that's what question marks are, right? They're variables or unknowns. Okay? I'm going to try and look at it just one more. And we'll look at something a little different, maybe that we haven't seen yet. Let's go. See, I've got log base 3 of 7 is equal to what? And in this case, I'll go x, all right? Now I'm going to convert this to, from the log form to the exponential form, and that should set us up to make sense of what x could be. So how am I going to convert it? I'm going to say that 3 to the x is equal to 7. So I really want you to try and follow this. And something that is understood here, that is, if this is equal to this, then I've got this. And then I can go the other way, right? Oh, right. I can say, if I've got this, then I've got this. So I'm going in this direction here instead of going in this direction. Does that make sense to you? I hope it does. It's a pretty simple converse statement here. Okay, so I've got log base 3 of 7 is equal to x. If log base 3 of 7 is equal to x, then 3 to the x is equal to 7. And now I can make sense of what x is. Like I could say, could x be 2? No, that would be too much, because 3 squared would be 9. So that's too much. Is x 1? No. So it's not 2, because that's too much. It's not 1, because that's too little. 3 to the first is equal to 3. So what is it? It's somewhere in between. It's in between 1 and 2. Now, if I want to know anything more precise than that, yes, I'll use a calculator. But I just want you to have a sense of it, just to know that, to be able to get to the point where when you see log base 3 of 7, you understand that you have a log, the log operation is operating upon 7, and you have an idea of what the value is. I don't care that we know what the exact value is. We can do that on a calculator any old day. But I want you to have a sense for it, to just be able to look at it and go, yeah, that's somewhere between 1 and 2. Okay? So that's an introduction to logarithms. And as with anything in mathematics, sometimes the understanding of it is harder than the doing of it. So hopefully you do get to a point where you can just do it. And but what I'm trying to do with this video is to give you some sense of it so that you understand what it is that you're doing.